Scott, good afternoon. I'm sure you're enjoying the picture that I'm proudly displaying here, the Golden Gate Bridge, painted blue to match our corporate colors. But seriously, the bridge does have something to do with Internet of Things, because it's a lot about building, connecting, securing, bridging. And these are all the things that are related to the Internet of Things. What is Internet of Things? Well, we all have been living past 10 years through impressive mobile revolution, when each and every of us got outfitted with at least one, or actually soon a dozen, devices that are computing and communicating. And it seems impressive. Well, there are many billions of us on this planet, and the revolution is going into the next phase with like wearable smart devices and whatnot. As impressive as it seems, the next, even bigger wave is rolling upon us, and that's Internet of Things. And that's about adding autonomous devices that compute and communicate without the intervention of a human user, without competing to your wallet or even share of attention. They connect autonomously, they compute autonomously, gathering the data from a multitude of sensors. With the help of the cloud tier, they process the data and generate certain actions that are automatically fulfilled by various connected actuators. And of course, because there is no limitation by the human factor, there is virtually no limit to the Internet of Things size and scope. So that's why we're seeing all those impressive numbers from analysts who are competing to each other, offering a larger, the more exciting projection for Internet of Things development. 50 billion devices, 50 zettabytes of data that they will generate that will need to be, communicated, analyzed, processed, and turned into actions. What is zettabyte, by the way? Anyone knows how many zeros that is? No one cares, right? Everyone knows that's a lot, and that's great. Well, how has that development been possible? Why is it starting or actually continuing today? Well, of course, one decisive factor is the significant drop of costs, the boost in availability of all these components that we're discussing here. Sensors, right? Bandwidth, because connectivity is a must for transmitting the data. And of course, being here from Intel, we pride ourselves on Moore's law, where it basically says about something about doubling the compute power or dropping costs by a factor of 2 every 18 months. So over the past 10 years, that translates to 60-fold drop in the cost of computing. Yeah. The propagation, the growth of Internet of Things depends on the fulfillment of a whole set of principles. And these developments in affordability of smart devices, of connectivity, of compute capacity, communication capacity, certainly contributes to fulfilling these principles. The founding one, the basic one, is actually security. Through the whole, basically, life cycle, through the whole connectivity cycle, through the whole processing cycle, through actually everything. The ease not only of drawing slides depicting Internet of Things development, but really of bringing those billions of devices online and connecting to the cloud, so to the data processing tier, in a matter of minutes or even seconds. It's about ingesting that unbelievable amount of data that's being autonomously connected by all the sensors and actually making sense out of it, figuring out what's important, what's not, what should be passed on to the cloud through the precious, even ever more affordable, but ever overloaded bandwidth. And then we realize, Internet of Things is not being developed by some charity. It's actually being developed and deployed by the industry, by a whole bunch of for-profit organizations. So somewhere, actually sooner or later, it should generate customer value, and it should generate the value for those who provide all those services. Therefore, we believe that it's a part of the set of principles to ensure the development of Internet of Things that we generate and visualize and make fillable the customer value, and that we provide the infrastructure for companies, organizations to deploy their services and actually get some value, a good value in return. Just as the analysts and experts are bold in naming the huge numbers measuring the potential of the Internet of Things, just as much they're careful setting the timeline when these projections will come true. Well, 50 billion devices, right? So when is that? Is it by the end of this decade or the next 10 years? You will see that DataQuest, IDC, and so on are kind of careful around that and giving in various papers various numbers. And that's because, of course, despite its enormous potential, despite the value that it delivers to the customers, to the users, to industries, the Internet of Things, of course, facing a whole array of challenges. And basically what this slide says about those challenges is that whenever those principles that were listed previously do not are not met, well, then we have a challenge. So starting with the founding element, security, right? Of course, the concerns about privacy, about the security, about increased vulnerability of the device of the things as they are becoming smart, so computing and connected, about compliance to the increasingly growing array of standards and regulations is very quickly named as number one concern whenever we're talking about practical deployment of some smart solution. It's also the clash of cultures as operational technology, so technology of operating things, meet information technology, technology of operating and running on data. Connectivity, we'll talk about that. That's, of course, yeah, great. We say connect and compute. Well, not as easy, right, with the connectivity challenges. Underutilized data. Yeah, well, those zettabytes, regardless how many zeros, very frequently the value that gets extracted out of that data is a single zero, yeah, or many zeros, but no one. So making sense out of data, putting in place the algorithms that extract the right data, analyze the right data. It's always been a challenge when a human was doing that, right, with Google or whatever. It's even more challenging for a device to do so. And then, of course, as always, when we're talking about something that's propagating across the industry, across the world, it's the challenge related to interoperability and standards. One challenge that I actually wanted to dig into is the phenomena that's actually related to the fact that we're now talking about things and industries. Each industry has grown historically its own sets of standards, devices, operational rules, and so on, that basically have mandated that the smart computing connecting solutions that emerging for these industries are necessarily specialized for those industries. So even at a conference like this one, right, we're hearing very interesting, insightful messages, updates about particular segment of Internet of Things. This is what's happening in smart home. This is what our company is offering to smart factories. This is our smart mobility solution. Of course, there is a strong drive in the industry to connect those islands of development, right? For example, the area of smart cities definitely involves smart mobility, smart car, smart energy, smart government, right, e-government, and so on. So just as much for the technology to be successful in the area of Internet of Things, we believe that it should developed towards producing ever larger share of horizontal, so usable across all those segments elements, both hardware and software components. Right? We see that the threshold of basically successful deployment across segments is somewhere around 60 to 70% of horizontally interchangeable, usable across segments technologies. So that, again, I start with security, that security models, security implementations that are common across multiple segments, manageability, data extraction, data analysis, API management, of course, very important, by definition supports this reusability. Technologies such as distributed computation and so on. And of course, coming from the organization that primarily works with developers, developer tools, technologies, building blocks, middleware that are applicable across segments, and so magnify the return on investment that I put into developing every particular solution. So this need for horizontalization is what drives the vision and the value proposition that we at Intel, together with numerous partners at the industry, are developing around IoT platform. We believe, as in the center of this slide, that it should contain reusable building blocks, yeah, of course, for faster time to market in every particular segment, and also for greater ROI, because it will be, the return will be growing across multiple segments, but the investment gets amortized across these segments at the same time. Actionable, that's about using those underutilized data sources. And of course, I already mentioned, it's not just us, it's a multitude of our partners, so it's secure, open, scalable, and open to collaboration. Such an IoT platform will offer those capabilities that are necessary to, well, if not completely remove, but certainly alleviate the challenges and fulfill the principles of successful IoT development. Easy connectivity across the devices, the devices that are secure and manageable, the data that's getting analyzed rather than just wasted, and exposed to now the human operators, users in the most meaningful way. Actually, the crown of good analytics is the predictability, when we can not only observe what's happening, but we can also predict things happening in the future. For example, can predict when this very hard to reach wind turbine somewhere in the North Sea will require maintenance, so that we do it on time and prevent it actually going offline and requiring major investment to repair or replace. Yeah, so just an example. Since all these parameters, from connectivity to predictability, will need to be delivered by these smart platforms all at the same time, of course, we need a right level of performance. So everything from the smallest sensor out there and to the thickest compute farm providing this analytics and predictions perform at the right level. Therefore, we will always highlight the need to optimize both hardware and software platforms to deliver this level of performance that actually makes the magic happen. Let me skip this slide. I mean, we talked a lot about successful customer journey and all the cycle from development, deployment, manageability, optimization, evaluation, to show this next nice picture that actually symbolizes the successfully deployed IoT platform. Basically as a reference model here, but we'll see how we fill it with concrete content. It starts here on the left with a whole array of connected devices, both gathering data and actuators acting upon the results of all the data analysis and predictions. A very important role is played here by the gateways. Just a sec, we'll talk about that in a little more depth to make sure that all computing, communication, data gathering, analytics that needs to happen on the edge, so before the data gets into the pipe and travels to the cloud, that it does happen and happens in the right way. And of course, once we reach the cloud, that's where the data, all zettabytes of it, turns into actionable insights. But that's not the end of the story, as we know. We need the economy to work in this picture as well. Therefore, with Intel, together with our partners, offer also a range of technologies, and that's on the right edge of this diagram, to easily connect, offer services around smart devices and the data that they produce and the data analysis, and then interconnect those services and create the offerings on top and then monetize those offerings. Here is a more formal diagram of Intel IoT Platform as a reference model. Again, filled in all of its tiers with concrete product offerings from Intel and from our numerous partners. On the edge, again, we see the array of sensors controlled and connected via gateways. And then once the data travels through the pipe, which is also actually should be highlighted here in a bigger way, because the pipe itself and connectivity protocols, you see a whole multitude of them, is an important tier of any IoT platform. And then goes into, in the cloud, backend processing, the whole way to the treating data as a service. And that's, of course, performed by today by a multitude of web APIs. Connecting the web APIs, that's where Intel Meshery, for example, technology offers very good solution, and service orchestration, such as offered by Epona. So all the range from the smallest sensor to the more sophisticated cloud analysis and value-add service is a part of this model and seamlessly placed together. Let us focus on what I already emphasized a couple times, on this gateway tier inside the edge tier. Before we go to the next slide, just notice the column of various connectivity technologies and protocols listed there, right? Wi-Fi, Bluetooth, of course, various flavors of those, a whole array of cell technologies, Zigbee, Z-Wave, and so on. Well, that's great that all these connectivity protocols exist, but how can we all use them and actually connect with them in a device that by definition should be very small, low power, autonomous? This challenge is addressed by an IoT Gateway. Yeah? So that's basically an interface device that exactly resolves this challenge of communicating with a whole array of various, a whole array of sensors and actuators connected by various protocols and technologies, supporting a whole range of those. That's, of course, not only the kind of dumb translator of protocols, but also a compute device that adds, again, let me start with security features, manageability, data encryption, and so on, but also add tremendous value by already performing smart functions on the edge, so before we send the data into the pipe and to the cloud, such as local data analytics, so selecting the right data or aggregating the data, producing this even predictive analytics, being smart about using the energy and switching things on and off, providing local storage and so on. So by deploying these gateway devices on the edge, we not only solve the connectivity problem, but also already deliver a good share of IoT services even before we hit the pipe and went to the cloud. That's kind of a whole list of things for a gateway to do, but at Intel we say there is actually one most important role that the gateway, IoT gateway plays. It's connecting the 85%. 85% of what? Well, it turns out that today, whatever the grand vision of IoT, today, 85% of devices deployed in factories, transportation, cities, and so on, are not connected, not even among themselves, leave alone to the cloud and to the internet, right? So that's a huge green field in front of us to get those devices connected, to get that data extracted, analyzed, processed, and acted upon. Yeah? That is, by our observation in many practical projects and deployments, is the frontier line of Internet of Things today, connecting the unconnected 85%. Well, we wouldn't be Intel if we stopped here at reference models, software stacks, and of course, a whole range of nicely packaged gateways that we started offering 2 years ago. We, of course, went further up or down, whatever, a point of view, and are offering a range in new, actually, families of CPUs, of chips, to power the gateways and smart devices. That includes our smallest CPU, Intel technology CPU, up to date, Intel Quark. It goes not only into a range of entry-level IoT gateways, but also into these nice Intel Galileo board, today already a second version of that is fully compatible with Arduino, and so allows not only professional developers and those industrial companies who are the established players in the Internet of Things playground, but also each and every of us, every developer, every student, even high school student, to start creating smart devices, to start testing IoT technologies for themselves, just using this open connectivity hardware provided by Arduino connectivity, and a whole world of software that's Intel compatible, so x86 compatible, right? Including, of course, a whole body of open source software that runs on this Galileo board. A slightly higher class of CPUs that were launched for smart gateways and smart devices, wearable devices as well, right, as I mentioned, is Intel Edison. That's already more solid compute machine, connectivity machine with two very capable Atom cores and an additional core playing the role of a real-time microcontroller. And as you would expect, not only we have a range of professional products with that chip, but also an Arduino-compatible development board. And we're proudly displaying several of those, actually several creations based on such boards at our expo booth right there. And I think in a sec my colleague will also show us a little demo here. Matthias, if you could join me on stage.
So what you see here is a similar demo to what you see outside at our booth. We do have Edison here, and there's a temperature sensor connected here to this heat lamp. I controlled here the heat lamp by my mobile phone. I could also...
I also have it here in the browser if you prefer.
I could also control it here with an Edison, which is here used just and powered only by a battery pack and communicating.
Okay, well, that's a small Edison development board without, of course, Arduino connectivity mechanically, but same capabilities. Yep. Mm-hmm.
Can you?
Yeah,
it's already here.
Yeah.
Okay, and I think you have to
toggle. Oh, to go to the.
Refresh the page. Okay, and here it streams the data to the internet, to the cloud, and it also sends some messages and alarms. And at a certain temperature, it gets an actuation event, and the LED will start blinking while the latency is too high, we would have to wait too long. It takes some minutes until the event comes, so you shouldn't use it for real-time purposes, but it's just here to demo it. I think you need to refresh the page.
Should I switch the lamp on? So that
no, you have to refresh the page, I think, at the...
Okay.
Yes.
Aha, okay. Yeah.
Okay, and now if you go to...
Also,
yes.
okay, now I can control just like you did from your phone. Because, of course, what we're demonstrating here is that little Edison-powered device here connected to the cloud. And from our user interface side, Matthias with his smartphone, me with the browser, connect to the same cloud, and through that can control the device and can watch the data being collected from that device and analyzed, okay, visualized. In this case, it's of course a simple temperature graph in the cloud as well. There would be nothing special, and that's definitely not a rocket science technology. What's impressive about that, the whole thing was created in 30 minutes, not by us with Matthias, but by one of the participants of our hackathons, just using the Edison Arduino compatible development board and the software building blocks to quickly and easily connect to the cloud. Just a sec, let me return to my slides. Connect to the cloud and create a real functionable IoT solutions with all attributes: smart sensors, smart gateway, cloud connectivity, and analytics in the cloud, and even user interface tier. These are building blocks that we provide as kind of reference model for development boards, both Edison and Galileo powered. As you see, there is no rocket science here either. That's just your regular vanilla Linux, Yocto distribution from Intel that are freely configurable, so you can build your own distro for your creation if you don't want to use our reference. A library layer that provides convenient bindings to all the I/O interfaces of the board, and supports a whole lineup of execution environments and programming tools. They are all also open source based, or they are standard Linux things. Here in your foils you will find a summary of development options that such boards offer. As you see, that's the whole spectrum. That's just, again, your plain open source x86 compatible Linux software, including, by the way, for diehards Arduino fans, okay, Arduino is there if that's enough for you. But you can go all the way to, actually, we see that happening in real life, to professional developments and products using C, C++ with Eclipse, or anything in between. If you're a scripting fan or coming from the app world, then JavaScript, Python, Java are also options. And even for novices, we are successfully using several visual, kind of intuitive programming environments, in this case provided by a company called Williodrin. It's a very, very nice thing. We invite you to visit the softwareintel.com/IoT slide to get more details on those options for developers. There is also an electronic invitation there to attend our, as I mentioned, hackathons, road shows. So if you click here, you will, for example, find out that the next IoT roadshow is taking place in Berlin next month, where you're actually getting a development board powered by Edison or Galileo, set of sensors to get you started and get your creativity going, and creating those cool devices and connecting them to the cloud. Okay, that's the array of sensors you're getting. So I'd like to wrap up by observing the fact that IoT is not only about converting the legacy world of a few centralized compute devices and unconnected machinery out there, replacing it by billions connected devices, but also about opening this world to the millions of new developers, of course from professionals, but all the way down to high school kids or even kindergarten kids. That unlocks probably the most important success factor of IoT, human creativity. Thank you very much.